High above the Minnesota landscape, this radio tower is equipped with unique sensing equipment that draws in air samples from hundreds of feet above the ground. Researchers at the University of Minnesota are measuring the concentration of carbon dioxide, methane, and nitrous oxide, trying to understand why the composition of the atmosphere is changing and what can be done to mitigate some of those changes.
We're very interested in why nitrous oxide is increasing, how it's affecting the planet. And what we find is that in agricultural regions where we use a lot of synthetic nitrogen, a significant amount of that nitrogen is converted to nitrous oxide by bacterial processes like nitrification and denitrification. And so we're studying how regional concentrations have been changing, and we've been making these measurements all the way back to about 2010 for nitrous oxide.
Dr. Tim Griffiths, a professor in biometeorology, says the university has been taking nitrous oxide samples here since 2010. They're finding the concentration is increasing by about 1 part per billion per year globally. Having accurate data is also helping researchers evaluate a range of mitigation practices.
One of the projects that Minnesota corn growers is helping us with right now is looking at strategies to mitigate large nitrous oxide pulses that happen during the spring period, during this spring thaw period. So this happens to be a really important period where nitrous oxide is released from the soil to the atmosphere. It actually accounts for about 35% of the annual N2O budget. And so, we're looking at ways that we could use cover crop strategies to reduce sort of freeze-thaw cycles, which seem to be responsible for these bursts of nitrous oxide to the atmosphere.
Griffith says long-term data serves as the benchmark to identify the trends and to assess the success of different mitigation efforts. He says the eye in the sky will help researchers discern whether or not they're making a positive impact.
There's been a significant investment of research funding into expanding these tower measurements across the Corn Belt. And so by having those additional towers, that'll give us much better temporal and spatial coverage and allow us to better understand the patterns of emissions and really help us to pinpoint and benchmark whether or not our mitigation strategies are going to work going forward.
This is Dan Lemke reporting.